Good morning, my dear students. Today I will discuss in this video about few numericals from the concrete structures. But before starting off the video or solving the numericals, we have to remember few important points. Point number 1. 1 cubic meter of cement is equal to 1500 kg cement. 1 bag of cement consists 50 kg of cement. Number 3, density of cement is 1440 kg per cubic meter. Point number 4, density of concrete is equal to 2400 kg per cubic meter. Point number 5, volume of dry concrete is equal to 1.54 multiplied the volume of wet concrete. Now this value 1.54, this can vary from 1.52 to 1.57. Now why we take this value and how does this value come? See, we know that during the concreting process, when we place wet concrete, it gets hardened after certain period. That means 30 minutes for the initial setting time and 10 hours for the full and the final setting time. Okay, so considering the same, it has been decided by the civil engineers that you should take a factor of safety ranging from 1.52 to 1.57 to counter that shrinkage. That's why we multiply the volume of wet concrete with 1.54 and then we get the value of volume of dry concrete. A room measuring 5 meter by 3.5 meter enclosed by brick wall has a ceiling at 3 meter height. The room has a door and a window opening of 1 meter by 2 meter and 1 meter by 1 meter respectively. The quantity of plastering required for interior walls in square meter is A. 46.5, option B 48, option C 51, option D 68.5. Let us see how to solve the problem. In this problem, we have to find the quantity of plastering required for the interior walls. So now area of 4 wall is 2 into within bracket LH plus B into H. So the calculation becomes 2. What is L? The value of length is 5 meter and the height of the room, that is till ceiling, it is 3 meters. So 5 into 3 plus what is the value of breadth? The breadth is 3.5 multiplied by the height, that is 3. So this comes out to be, calculation is 51 meter square. Let us name it as equation number 1. Now area of one door is 1 into 2, that is length into breadth, that is 2 meters square. Area of window is 1 into 1, that is 1 meter square. Let us take name both this value as equation number 2. Now what is the quantity of plastering required? The quantity of the plastering required is, total is the area of the 4 wall is 51 minus area of door minus the area of the window, because that we do not have to plaster, so that comes out to be 48 meter square. Now suppose this problem can be extended like this way. Let us discuss that. Suppose in question it is asked that if the ceiling is also has to be whitewashed or plastered, what it would be. So how would we do the problem? So in that case the total area will be the area of walls, that is 51, already we have got it, plus what is the area of the ceiling? The area of the ceiling will be the length and the breadth of the room, that is 5 into 3.5. So that comes out to be 68.5 meters square. So what will be the quantity of plastering in that case? In that case it will be 68.5 minus 2 minus 1. Similarly, the area of the door and the area of the window have to be subtracted. So it comes out to be 65.5 meters square. Let us start. Volume of coarse aggregate in cubic meter present in 1 cubic meter of 1:1.5:3 concrete mix made by volume batching is. Let us see how to solve the problem. In the question, the nominal mix ratio is given as 1:1.5:3. It means that 1 is the part of the cement, 1.5 is the part of sand and 3 is the part of the coarse aggregate. So total parts will be 1 plus 1.5 plus 3, that is 5.5. Now the coarse aggregate part will be 3, or the volume of the coarse aggregate will be 3 divided by 5.5, that is from the ratio we have got 3 and the total part is 5.5, that is 0.54 meter cube. Next question, cement in cubic meter required for preparing 10 cubic meter of cement concrete in the proportion of 1:2:4 is option A 0.8, option B 1, option C 1.2, option D 1.4. Let us see how to solve the problem. In this question, the cement concrete is given as 10 cubic meter. Nominal mix is given as 1:2:4. So total parts will be what? 1 plus 2 plus 4, that is 7. Out of this, what will be the part of the cement? Cement will be 1 divided by 7. Now to prepare a 10 cubic meter of concrete, the cement required will be 1 by 7 multiplied by 10, that is 1.4 cubic meter. The area of 200 millimeter thick slab in square meter that can be cast using the entire 10 tons of concrete will be option A 10, option B 15, option C 20, option D 25. Let us see how to solve it. In this question, the slab thickness is given as 200 millimeter. It is given. Now that means 200 millimeter means 0.2 meter. Now mass of the concrete is given as 10 tons. So let us denote the mass of the concrete as capital M. So 1 ton equal to 1000 kg. So 10 tons will be 10 into 1000 kg. That means 10,000 kg. Let it be like that way. Now density of the concrete, let us denote it as capital D, is 2400 kg per meter cube. As I have already told you that please remember these standard values. Density of the concrete, density of the cement, all these values. Okay, now we know density is equal to mass by volume, that is capital D equal to capital M by capital V. Now what is the volume? Volume is equal to cross sectional area into the thickness. So let us say the cross sectional area is capital A, and what is the thickness of the slab? That is 0.2 meter. In the first line you can see. So now put the value in equation number 1, that is capital D equal to 2400, that is equal to mass equal to 10,000 divided by A into 0.2. So that gives us the area is equal to 20.83 meter square. So in the question you mark the option C, that is 20. Next question, calculate the volume of cement in cubic meter required for making 10 cubic meter of M20 grade cement concrete work, assuming the ratio of dry concrete mix to wet concrete mix is 1.52. Let us see how to solve the problem. In the question, the dry concrete to wet concrete ratio is given as 1.52. Please take a note, in this problem this value is given. Okay. So what will be the dry concrete? Dry concrete will be 1.52 multiplied by wet concrete. Now the value of the wet concrete is given as 10 cubic meter. So the dry concrete will be 1.52 into 10, that means 15.2 cubic meter. Okay. Now nominal mix ratio for M20 concrete is 1:1.5:3. So here if you are confused with it or can't remember from where this value I have got, please refer my video on IS 456 codal specification, and you can find this table I have already mentioned at 3 minutes 50 seconds. There you can stop and see the entire table is given. So please remember or memorize the table for these values. Okay, now let us proceed. Now volume of the cement will be how much? 1 divided by 5.5. multiplied by 15.2. What is 5.5? 5.5 is the total parts. 5.5, 1 plus 1.5 plus 3, 5.5. And how much is the cement? Cement is the part 1. So 1 by 5.5 multiplied by 15.2. What is 15.2? That is the volume of the dry concrete we have found out in the first step. So that gives the answer as 2.76 cubic meter. Okay, so that is the answer. But this problem I just want to extend that this is the past question paper we are solving, but it can be modified like this way. You have maybe some year they will ask you that find the volume of the fine aggregates, that is the volume of the sand you find. So how we will find the volume of fine aggregate or the sand will be 1.5 divided by 5 is 5.5. 1.5 value from where I have got it? From the ratio 1 is to 1.5 is to 3. That means cement is to sand is to coarse aggregate. So 1.5 divided by 5.5 into 15.2. So that gives 4.14 cubic meter. Similarly, the volume of coarse aggregate will be 3 divided by 5.5 multiplied by 15.2. So that gives us 8.28 cubic meter. In India, for 1 cubic meter of M20 grade concrete, the number of cement bags required is, you have to find the answer up to 2 decimal places. Let us see one last numerical from GATE, that is in this let us see that how to solve it. So M20 grade concrete is given and 1 cubic meter concrete we have to make. We have to find that how many cement bags are required. Okay, so let us start. Nominal mix for M20 is equal to 1 is to 1.5 is to 3. We already know. Refer my refer my video of IS 456 codal specification. There you will find this value. Now total parts will be how much? 1 plus 1.5 plus 3, that is 5.5. Now volume of dry concrete will be equal to 1.57 multiplied by volume of wet concrete. So volume of dry concrete will be 1.57 multiplied by 1. Why? Because it is given in the question that we have to prepare 1 cubic meter of concrete. So volume of dry concrete will be how much? 1.57 cubic meter. Correct? So volume of cement, how we will find? Volume of cement will be 1 divided by 5.5 multiplied by 1.57. 1, how we are getting this value? 1 we get from the value of ratio 1 is to 1.5 is to 3. From there we are getting 5.5 is the total parts. Okay, and 1.57 is the volume of the dry concrete. Okay, so volume of cement we are getting as 0.285 meter cube. Now weight of the cement, weight how we will find? Weight of the cement we can find by volume multiplied by density. What is the volume? 0.285. What is the density? You have to remember the value. Density of cement is how much? 1440. Okay, so this gives the weight of the cement as 411 kg. Now we know that in one bag 50 kg of cement is there. So for 411 kg, how many bags we require? 411 divided by 50, that is 8 bags.